Have you ever got tired by those little pesky advertisements that you see on the TV? Well, I have. Today we are going to find a solution to tackle this problem. So let's see. Welcome to Software Side, a space dedicated to discussing software development and crafting solutions to various challenges through coding. Now, back to the problem. You see, like many of you, whenever I watched the TV, I was fed up with the barrage of ads invading my TV screen. So I decided to take matters into my own hands and find a way to block them out. My journey began with some research, and I stumbled upon a fascinating project by Matt Richardson. This project was made with Arduino and used closed caption feed in the cable channel. But the challenge was that in my TV, the closed caption was not available, and I needed to find a way to overcome this. After some research, my initial idea was to use audio fingerprinting. An audio fingerprinting is a condensed digital summary of fingerprint generated from an audio signal that can be used to identify an audio sample or quickly locate similar items in an audio database. This is the technique used by apps like Shazam and Google to identify music by listening to a small part of it. I intended to record a lengthy audio clip, create its fingerprint, then record a brief segment of the same audio and generate its fingerprint as well. Subsequently, I aimed to compare the two fingerprints for a match. So to try out this thing, I used the Echolib library from the GitHub. I started to integrate the library. With this library, I was able to generate both the fingerprints. However, despite my best efforts, I encountered some challenges. The matching score was too low, so that I was unable to match the fingerprints. Also, the algorithm that I used for fingerprint matching took quite a bit of time. After hitting the roadblocks, I realized it was time for a different approach. Now I was back at step 1. And I decided to make use of AI. My idea was to use a machine learning model that can transcribe speech to text. Thus, I embarked on creating a mobile app armed with a speech-to-text model. The app must be capable of transcribing TV audio in real time. The app will continuously listen for the keywords from a watch list that we will create, and upon detection of a keyword from the TV audio, the app will send a new command to the TV. This idea seemed promising, prompting me to dive right in. I opted for Mozilla's Deep Speech model, which conveniently offered a TensorFlow-like version available for download on their GitHub repo. Integrating it into the application was straightforward, albeit requiring some trial and error. Initially, I tested it with a local audio file and found the text output to be accurate, signaling progress. The subsequent steps involved capturing audio via phone's voice recorder, for which I utilized the home recorder library. This perfectly suited to our needs. With this setup, audio could be recorded in a manageable chunks and fed into the model. After several attempts, I successfully obtained accurate text output from the model, demonstrating its efficacy in converting audio to text. Now moving on to the step 3, my focus shifted to establishing communication between the application and the TV. Given that I am utilizing an Android TV, I aim to incorporate TV remote control functionality into it. Initially, I anticipated this to be a straightforward task, only to discover challenges with the outdated implementation and lack of official documentation for newer versions. Despite investing considerable time into exploration, I realized this aspect wasn't central to our project's core innovation. As a workaround, I found this library, which was a non-JS implementation of the Android TV remote control, and I decided to use it. This enabled our device to communicate with a local server, hosting the remote service, granting control over the TV. While this approach didn't fully meet my expectation, my determination to complete the project drove me forward. Persisting in setting up the communication channels between the application and node server eventually proved successful. Now that we are confident that the entire system will function as intended, it's time to design the app's interface. I swiftly crafted the UI and performed some code optimization. With the design in place, it's crucial to conduct thorough testing. I iterated the keywords from my test video and ensured everything was set up correctly. Upon detection of these keywords, the TV promptly muted itself, automatically unmuting after 10 seconds. With this solution in place, I can finally bid farewell to those bothersome ads during my TV time. Now reflecting on this project, there are areas where improvements could be made. Occasionally, the model's output wasn't accurate, potentially due to the input audio noise or the model's performance. Exploring better models in the future could address this issue. Also, the inability to include the remote control functionality within the app itself was a drawback, but it's a challenge we aim to overcome in future iterations. Despite these challenges, I am pleased with the outcome of this project.
What? I see this as an absolute win.
If you found this video interesting, please consider subscribing to this channel. See you in next video.